effet, je suis très heureuse de voir de nombreux amis se joindre à nous. Au nom de Huawei, je tiens à vous exprimer nos sincères remerciements. À l'heure actuelle, le monde s'unit pour relever le défi de la pandémie du Covid-19. Les TIC jouent un rôle important dans la lutte contre ce fléau et visent également à la reprise économique. Tout cela sera à travers la communication de données et la technologie centrale de connexion. Soyons témoins de la façon dont les ingénieurs Huawei travaillent avec leurs clients et partenaires en Afrique du Nord. Même pendant la pandémie, le réseau est toujours stable et sans entrave, laissant la communication de données nous connecter, vous et moi.
Hi everyone, I'm Bob Chen. Welcome to IP Club, a fully connected, intelligent world is fast approaching. Campuses will become the seals that carry all the DNA needed for this world. Recently, my friend asked me, while we often see wireless and intelligence as the main features of campuses, has Huawei's campus become fully wireless and intelligent? I replied, yes, absolutely. Today, my colleague will take you on a tour of a fully wireless, intelligent campus, the Huawei Songshan Lake campus. I'm sure you will find the answer there. Okay, let's get started.
Hello and welcome to our Songshan Lake campus. I'm Wu Fan, one of over 190 Huawei employees who are dedicated to helping our customers succeed in over 170 countries and regions. Our Songshan Lake campus is located in Dongguan, China. The campus has over 600,000 square meters of office space, 200,000 square meters of labs, and more than 800 meeting rooms, 15 canteens, and 10 coffee shops. Over 25,000 employees work here. Today, I want to share with you how our campus network makes a difference. At Huawei, 2.8 million emails are sent every day, while more than 600 applications are running our network system, including IPD, ISC, CRM, IFS. Without this process, platform, application, Huawei employees simply cannot work. But what empowers this system? The secret is a secure, reliable, and stable IT network system. Huawei IT has undergone 3 phases of development, that is, globalization, digitalization, and intelligence. Our Songshan Lake campus is designed and built in line with the 3rd phase, which includes intelligent workspaces, services, and production. All of these are built on a unified network architecture, which defines dozens of standard service modes and combine this service mode to serve a variety of scenarios. In a moment, I will show you around this unique campus. As we drive into the campus, our phone notifies us about real-time parking spaces and routes. Simply picking a free parking space will then bring up the directions to get there. Even at peak hours, our administrator can flexibly allocate resources to guarantee the best experience for VIP. How do we achieve this? Well, the answer is smart radio lossless roaming and precise positioning, which is powered by Huawei's Air Engine Wi-Fi 6. Next, I will let my colleague to introduce our meeting booking system.
Hello everyone, my name is Guo Peng. Next, I will show you how we book a meeting inside Huawei. To ensure all the meeting rooms are used as much as possible, all our meeting rooms are networked and digitally transformed. A tablet is installed outside of each meeting room to display real-time information. All of this powered by our central IT platform, ensuring a smooth room booking service and greatly improving team communication and collaboration. As soon as we enter the meeting room, the curtains close, the lights and the air conditioner turn on automatically. The enabler behind the comfortable environment is the built-in IoT modules in the Wi-Fi 6 APs. In each meeting room, tablet, computer, smartphone, and touch screen are connected using wireless network, supporting smooth switching between screens. The high bandwidth and low latency of Wi-Fi 6 allow us to enjoy uninterrupted experiences while using CAD or real-time video and voice services.
All of our offices at Songshan Lake campus have now become fully wireless. Previously, wire network was used, where one network cable had to be routed for each cubicle. This means that network deployment was complex and time-consuming. But now, we can use a single AP here to connect to dozens of even over 100 users at the same time, which greatly simplify deployment and network access. As Wi-Fi 6 is rolled out, we have upgraded the ordinary access switch to hybrid optical-electrical multi-G switch. Such switch can auto-negotiate for 2.5, 5, or 10G speeds on ports. They can also work with hybrid cable to supply directly connected APs and cameras with 60-watt PoE++ at an ultra-long distance of 300 meters, breaking the 100-meter limitation and previous PoE. This ensures reach anywhere on each floor, significantly simplifying cabling and saving valuable equipment room space. We affix RFID tags to all important access and connect them through Wi-Fi 6 AP built-in IoT module for unified management. This brings two false benefits. One is to facilitate access accounting and geofencing alarm to ensure access security. The other is to support easier collection of statistics on access usage, thereby maximizing access outcomes and allocations. Wi-Fi 6 is available throughout the campus, so we can enjoy the fast internet access anytime, anywhere. For example, I'm in Canton right now.
The Wi-Fi network is really convenient for everyone, but it might encounter poor performance when people gather in crowds.
Hi. Now it won't be an issue because we introduce a powerful intelligent OM tools, which is Campus Insight. Campus Insight also supports big data-based optimization and intuitively display post-optimization gains. Specifically, it uses AI algorithm to identify high-load AP and edge AP based on historical big data, perform intelligent radio calibration on devices according to the result, and virtually display the records. Now, let's take a look at the real-time running status of Huawei's global network. We will use meeting resources as an example. In fact, over 80,000 meetings are held every day at Huawei. On the last screen, we can virtually see the connection status, bandwidth, and packet loss for all parties in the meeting. If an exception occurs, we can simply click the repair button. Then the system attempts to rectify the fault by switching links, changing QoS policy, adjusting transmit channels, or suppressing adjacent core channel interference based on the default setting made by the administrator. If the default, such as insufficient bandwidth or fiber faults, persist, the system provides root cause analysis and faulty device location, and then reports such alarm to O&M engineers. This dramatically improves O&M efficiency. Huawei not only has its own office campus, but also has its own large production campus. Next, we will look at it and see some of the cutting-edge technology it uses. Huawei's production campus is highly intelligent as it uses the innovative technology of Huawei's cloud campus solution. Key highlights including intelligent logistics, production lines, management, and the others. In particular, hundreds of AGVs in high-density area seamlessly move and operate in accordance with scheduling instructions without experiencing any packet loss. Automatic production is seamlessly coordinated in all phases. This changes from people wait for materials to material wait for people, maximizing efficiency and facilitating smart logistics. The industrial unique Huawei Wi-Fi 6 CPE module quickly transformed the wired into wireless transmission, enabling network availability upon module power on. This capability, combined with 10G fully wireless uplink capabilities offered by Huawei's cloud-managed network solution, enables dozens of AOI devices in the production line to collect and migrate hundreds of months of image data onto the cloud without any packet loss. As such, quality detection can be completed in seconds at a greater accuracy and speed that manual methods can achieve. At Huawei's Dongguan Southern factory, we use Wi-Fi 6 and IoT technology to locate materials verticals at high precision of centimeters, trace them, and intuitively display the information and status of materials in real time. This prevents any material waste from entering the production line, ensuring high quality and reliability of products. We also leverage the automatic network policy provision and intelligent ONM capabilities of Huawei's cloud campus solution. Specifically, we can quickly simulate the impact of production line service policy changes and automatically commission network functions. In this way, the network can flexibly adapt to changing production requirements and reduce unplanned downtime, ultimately achieving intelligent, flexible manufacturing. Huawei's intelligent campus network revolutionized our workspace, work, and lifestyle. For example, we have introduced cloud-managed network to thousands of our retail stores around the world, significantly simplifying network deployment and improving network management efficiency. As more services migrate to the cloud, we have also adopted our SD-WAN solution for branches. This optimizes network links and enhances service quality. Our cloud campus solution has unique features such as fully wireless access, one global network, cloud management, and intelligent ONM. Within this feature-rich solution, we have moved the Songshan Lake campus into a new era of work productivity and technology. This has resulted in increased office collaboration efficiency by 30%, reduced overall energy consumption by 10%, increased administrative operation efficiency by 30%, and enhanced production line efficiency by more than 50%. Okay, that's all for today, and thank you for your time. Bye-bye.
Pour commencer, je souhaite la bienvenue à Monsieur Brandon Butler, analyste recherche senior de l'IDC et réseau d'entreprise. Son thème est comment la maturité des réseaux sans fil d'entreprise impacte la transformation numérique. Accueillons-le.
Hi, my name is Brandon Butler. I'm a senior research analyst at IDC, where I cover enterprise networking. And I'm going to speak to you today about how wireless network maturity impacts digital transformation. It's a real exciting time in the enterprise networking market right now. We see a lot of enterprises looking to digitally transform themselves, and they're increasingly realizing as they are digitally transforming themselves how important enterprise networking technology is to the digital transformation journey, and specifically how important wireless networking is to the DX journey. So let's get started. I want to level set and talk about where we are in the digital transformation journey for enterprises. IDC talks about how we are currently in what we call the third platform of digital transformation. You can think of the first platform as the mainframe era, and you can think of the second platform as being the client server era. Over the last 10 plus years, since about 2007, we have entered what we call the third platform. And this is defined by some of the new technologies that we've seen come into market in the last decade or so. Things like cloud computing, ubiquitous mobile connectivity, big data analytics, machine learning, and artificial intelligence. All of those are what we classify as the third platform. And we see three distinct stages within the third platform, which we call DX1, DX2, and DX3. So the first stage of the third platform was really around experimentation, and that was the DX1 stage. This was when the advent of some of these new third platform technologies like cloud, mobile, and social really came into place. And we now have entered into a DX 2.0 phase of the third platform, which we call the phase of multiplied innovation. This is where enterprises are using these third platform technologies, and as they're doing so, they are getting increased levels of innovation from using those technologies. So these are technologies like artificial intelligence, such as Internet of Things, blockchain, and natural interfaces. And we see platforms and communities being developed around this DX 2.0 stage. And this is basically where we are today in terms of enterprise adoption along their digital transformation journey. And we're on the cusp of entering this DX 3.0. A third stage of the third platform journey. And that is really going to be about autonomous use of third platform technologies. So this is where you get exponential value out of artificial intelligence. This is where we'll see quantum computing come and play an important role. And so some of these innovations are going to be very important over the coming years. But the key here is that in the third platform era, the network is critically important for delivering third platform technologies. And as we think about the networking requirements that enterprises have to face on a daily basis, those are continuing to expand and continuing to put pressure on enterprises as they think about their network. Now, there are three big challenges that we see enterprises facing as they're looking to digitally transform themselves and in turn transform their networks as well. One of the challenges is around the number of connections, the number of users and devices that are on the enterprise network today that must be supported. There are billions of connections that must be supported in enterprise networking today. We estimate that there could be up to 31 billion IoT devices in the world in the coming years. And so this huge increase in the number of devices is really putting strain on enterprise networks. The other factor that we see, the other challenge that we see, is the increase in bandwidth intensive applications and use cases. So if you think about some use cases like virtual reality for education or shopping or traveling or telemedicine, these are very bandwidth intensive applications that enterprises are looking to support. And that is putting strain on the enterprise network as well. And then the third major challenge is that there's this expectation of low latency connections. And so users and devices and workers and guests are expecting to have low latency connections when they're on the network. And so if you put these three factors together, it's really creating strain within enterprise networks today. And it's causing organizations to realize that if they want to digitally transform themselves, then they need to transform their networks to make sure that their networks are able to keep pace with the digital transformation that they're looking to support. And you can see the graph on this slide shows some of the important use cases that we see enterprises supporting in digital transformation. Like I talked about, virtual reality is a key one. Financial transactions that are real time, having a smart factory or a smart city or a smart car. These are some of the other use cases that combine these three challenges of more devices that need to be supported, higher bandwidth applications, and a requirement for lower latency connectivity. So as we move on and focus a little bit more on the enterprise network, these are some of the key drivers that we see driving investments in enterprise networks today. IDC recently conducted a survey of enterprises asking what are the top factors driving your organization's future investments in the enterprise campus network. And you can see some of the top drivers for enterprise networking technology today include security, user experience, and automation. These are some of the key drivers that we see enterprises looking for as they're making investments in their enterprise networks. And they're also thinking about what these enterprise networking platforms have to enable. And so they're looking for advanced automation. They're looking for advanced platforms that can enable secure policies throughout all areas of the network. Enterprises are looking to assure high quality experiences for users and devices on the network. And finally, enterprises are looking to enable advanced automation of the network as well. And so again, these are some of the factors that we see within the enterprise networking market specifically that are really driving the investments that we see from enterprises as they think about transforming their networks to support digital transformation. So let's talk about the importance of wireless within the enterprise networking market today. Wireless networks have become really a primary connectivity method for enterprises today. We've really seen a shift in the last handful of years in terms of the use cases that enterprises are relying on wireless networks for. It's really expanded from the basic Wi-Fi connectivity in a carpeted enterprise use case to this whole new swath of digital transformation use cases that we see enterprises supporting within their environments today. And they're using Wi-Fi as a primary connectivity method for many of those use cases today. So really Wi-Fi is expanding out from the traditional use cases of delivering enterprise applications. And really it's expanding out to manufacturing and smart factory use cases, into telemedicine in the healthcare industry. There's a whole number of use cases that we see enterprises pursuing, and they're relying on wireless connectivity to enable those use cases. Wi-Fi and wireless networks also connect users and devices to business critical applications. As you think about the importance of voice and video collaboration, unified communications, and cloud-based applications that enterprises are increasingly relying on, workers and guests are increasingly relying on Wi-Fi connectivity and wireless networks to connect to those business critical applications. And there's another key here that Wi-Fi provides granular segmentation and access controls for enterprises. This is hugely valuable for enterprises. Wireless networks and Wi-Fi specifically have really fine-grained access and usage policies that enterprises can manage within the enterprise network to enable segmentation and access controls. And that really increases the value of wireless networks for enterprises today. And so as we talk to enterprises about what sort of goals they have in supporting enterprise wireless networks today, they're looking for ubiquitous gigabit connectivity. They're looking to guarantee application and user experience. And they're looking to ease operations both on day one deployment of wireless networks and also day two management of wireless networks. And the key takeaway here for me on this slide is that you can't just rely on the infrastructure components of wireless or the software management capabilities of wireless as you think about transforming the network. Really, you need both of these components to be coming together. And we see that happening in the enterprise market today, in the wireless market today. We see advanced infrastructure components coming about with the advent of Wi-Fi 6. And we see advanced automation and software-based management platforms that run atop wireless networks that are increasingly being enhanced by artificial intelligence and machine learning for managing these networks. And when you combine the infrastructure components with the software components, that's really going to allow enterprises to meet the digital business needs of their enterprises into the future. So as a final slide here, I wanted to talk about some essential guidance for enterprises that you can think about to spur on the maturity of your wireless networks today. So if you want to be more mature in your wireless networks today, here's some advice on how you can go about doing that. Really, the first piece here is realizing that wireless maturity enables faster digital transformation. So if you want your organization to be able to be more digitally transformed, wireless networks are a key component for being able to enable that, to enable faster digital transformation. One piece of advice I would have is to enable and embrace automation over manual management wherever possible in the wireless network. Given the scale of the number of users and devices, the level of bandwidth and traffic that enterprise wireless networks need to support today, you really need to rely on automated management. If you're relying on manual management, it's just not going to be able to scale to the efficient way that is needed in enterprise networks today. Another piece of advice would be to plan for wireless investments both across the infrastructure and as well as the software management capabilities. And so again, we're seeing some advancements in Wi-Fi 6 on the infrastructure side, but also in the management platforms atop wireless networks today with the machine learning and artificial intelligence enhanced automation. One of the other trends that we see is the use of cloud managed networking for faster deployment and easier management. This is another way that enterprises are making sure their networks are more mature, is having a cloud-based platform for being able to manage, specifically when you have multiple sites that you need to manage at once. Having a cloud-based platform can be very important for that. And finally, and this is probably the most important piece of advice I have, is that to ensure that your network transformation goals align with your broader business development goals. So really, it's important to have ensure that as you're making investments in your enterprise networking technology, in your wireless technology specifically, make sure that those investments are in line with the goals that your broader business has for improving user experience or guest experience, for example, or enabling more connected devices in a smart factory, or enabling students to use AR and VR in an education setting, for example. Whatever your business's requirement and goal is for digital transformation, let that be the investment driver for investing in more advanced features within your enterprise network and specifically within the wireless network. So with that, I'm going to wrap up here, and I just want to say thanks for listening to my presentation. This wireless LAN maturity and benchmark survey is going to be published within the coming weeks and months, and I really hope that everyone here listening today has a chance to look at it. to really help guide your journey through digital transformation, through network transformation, and really realizing the importance that wireless networking can enable for advancing network transformation and digital transformation. Thank you very much.
Merci Monsieur Butler. La prochaine session aura pour titre le Wi-Fi 6 Air Engine accélère la transformation numérique d'entreprise avec l'innovation technologique. Je vous laisse maintenant avec Monsieur Youssef Boukari, expert IP de Huawei Afrique du Nord.
Bonjour, je m'appelle Youssef Boukari, je suis directeur de solutions au niveau de Huawei IBG Nord d'Afrique. Aujourd'hui, je vais vous introduire les innovations technologiques au niveau de notre solution Air Engine Wi-Fi 6. Comme vous le savez, les réseaux d'entreprises utilisent actuellement le Wi-Fi. Il est bien adopté. On est dans une ère plutôt de réseau Wi-Fi. 70% des réseaux campus utilisent déjà le Wi-Fi dans plusieurs secteurs d'activité et pour plusieurs types d'applications, telles que les applications de collaboration, les applications Office et un peu moins pour les applications métiers. Dans le cas de l'éducation, le Wi-Fi assure la mobilité des élèves et des étudiants et assure une connexion anywhere, anytime. Pour le cas de la grande distribution, le cas de Lidl en Allemagne, donc l'introduction des robots et des véhicules autoguidés au niveau de cette industrie nécessite également le déploiement d'un réseau Wi-Fi fiable. Dans l'industrie 4.0 et dans la télémédecine, le Wi-Fi est nécessaire également pour assurer une connectivité aux objets connectés. Pour le cas de la digitalisation bancaire, donc les smart banking, donc les smart branches utilisent également le Wi-Fi pour interconnecter et connecter les caméras afin d'assurer la reconnaissance faciale du client et pouvoir diffuser un contenu adéquat au client. D'autres cas d'usage, les connexions hotspot en outdoor utilisent également le réseau Wi-Fi public. Et malgré que 70% des réseaux de campus utilisent déjà le Wi-Fi et l'adoptent pour plusieurs types d'applications, 33% de ces entreprises sont insatisfaites de la qualité de réseau Wi-Fi déployé, dont 36% lient ces problématiques par rapport à la bande passante par utilisateur. Ça veut dire que certaines applications ou certains types de services ne sont pas fonctionnels. Ils ne garantissent pas une meilleure qualité expérience client sur le réseau Wi-Fi déployé. 28% des non-satisfactions lient les problématiques par rapport à la mauvaise couverture et 21% le lient par rapport aux problèmes de roaming et donc à la perte de paquets et de connexion. 15% lient les problématiques au faible troubleshooting, aux problèmes de gestion et cette incapacité d'avoir des solutions intelligentes pour pouvoir anticiper et minimiser, réduire la partie opérationnelle. C'est pour cette raison qu'on a pris en compte tous ces aspects-là lors de développement de notre solution Air Engine Wi-Fi 6 qui se caractérise par la haute capacité, la bande passante par utilisateur, les faibles latences et également le packet loss durant le roaming. Donc, ce qui permet, bien entendu, de résoudre toutes les problématiques qu'on a citées au début. Quelques comparatifs avec la compétition. En fait, on est en train de dépasser la compétition sur tous les axes. En fait, sur la partie multi-user MIMO et OFDMA, donc, nous, on arrive à les utiliser conjointement, ce qui nous permet d'avoir plus de capacité, plus de bande passante, couplé avec les software defined radio pour minimiser les interférences et pour ajuster et faire l'autocalibrage. Donc, chose qui nous permet de dépasser la compétition de 40%. Sur le deuxième axe, donc, on utilise déjà les antennes intelligentes qui nous permettent d'avoir plus de 20% de couverture par rapport à la compétition, avec des antennes directionnelles adaptées. Le troisième axe, c'est le less roaming, et donc on garantit un roaming smoothly sans perte de paquet. Le quatrième axe, c'est la partie intelligence de la partie gestion, O&M. Et donc, nous, notre solution eMaster NCE Competition Site dépasse la compétition et garantit, bien entendu, une visibilité et une proactivité par rapport aux problématiques réseau. Là, le cinquième axe, c'est la partie IoT. Et donc, notre solution embarque et intègre des slots IoT nativement, donc sur tous les points d'accès Wi-Fi 6, donc ce qui permet bien entendu d'optimiser et d'avoir un seul réseau unifié garantissant la connectivité aux endpoints et aux objets connectés. Donc, le premier concept, c'est on arrive déjà à utiliser conjointement le OFDMA avec le multi-user MIMO. Donc, du fait, on utilise les ressources de fréquences inutilisées et de façon à avoir plus de capacité et plus de connexions simultanées et plus de bandes passantes. Donc, et grâce à l'utilisation des antennes intelligentes, donc avec des modules bien adoptés et avec des antennes directionnelles adaptives, on est capable de minimiser l'interférence et d'avoir une bande passante qui peut aller jusqu'à 10,75 gigabits par seconde. Un deuxième volet, c'est on est capable également, en utilisant ces concepts, d'adresser des environnements denses utilisateurs tels que les stades ou bien les salles de conférence. On est capable d'aller jusqu'à connecter un certain nombre d'utilisateurs simultanés qui dépassent la compétition. Donc, du fait qu'on utilise des points d'accès allant jusqu'à 16 flux spatiaux en transmission et en réception, donc on est capable de développer jusqu'à 10,75 gigabits par seconde sur les deux bandes de fréquence 2.4 et 5 GHz. Chose qui n'est pas possible au niveau de la compétition. Ils peuvent aller jusqu'à 9,6 gigabits par seconde. Le concept également, un nouveau concept qui est le Software Defined Radio. Et donc, c'est un concept qui nous permet de commuter entre les modes radio selon l'environnement sur lequel on est connecté. Donc, si on est dans un environnement qui demande plus de bandes passantes et moins d'utilisateurs, donc on utilise le mode double radio. On commute vers le mode triple radio si on est dans un mode, dans un environnement dense, mais avec moins d'exigences en termes de bandes passantes. Et on peut utiliser le double radio avec une radio dédiée pour le scanning dans les environnements où il y a plus d'interférences. Donc, comme vous voyez, donc, la solution s'adapte à plusieurs use cases, à plusieurs environnements. Le lossless roaming, comme j'ai précisé, donc, on pourra assurer un roaming sans perte de paquet grâce à un système de cache intelligent. Et donc, les états de connexion seront envoyés, anticipés et envoyés au point d'accès suivant pour ne pas avoir de la perte de paquet. Et donc, on assure un roaming avec des latences inférieures à 10 millisecondes avec zéro packet loss. Un autre concept, c'est la partie IoT. Nous, nos points d'accès intègrent des slots IoT, un ou deux slots, selon le modèle, qui permettent, bien entendu, ces techniques-là permettent de faire fonctionner des applications IoT telles que RFID, telles que Zigbee, telles que Bluetooth ou Thread. Et donc, tout ça, c'est grâce également à cette intégration. Et donc, on pourra également sur nos routeurs Wi-Fi 6 intégrer également, assurer plusieurs fonctions. Donc, l'utilisation derrière tout ça, on a une solution ONDM intelligent qui est notre Master NCE Computing Site qui permet d'auto-calibrer les radios et de minimiser l'interférence. Donc, chose qui permet bien entendu d'avoir un réseau qui fonctionne d'une façon optimale. Et donc, ça permet également d'anticiper les failures. Donc, c'est une solution intelligente qui récupère les flux moyennant du NetFlow, NetStream et qui, moyennant la machine learning et le big data analysis, donc permet d'anticiper, de détecter les scénarios de failure probables. Donc, on a plusieurs références dans plusieurs secteurs d'activité, comme j'ai précisé. Le cas de l'université Jiaotong University, donc on a déployé une solution Air Engine Wi-Fi 6. Donc, ici, on cite quelques exemples dans plusieurs industries. Et donc, où on a pu assurer des latences inférieures à 10 millisecondes et on a pu, bien entendu, augmenter la bande passante et la capacité de 40%. Également pour la partie grande distribution et asset management, on a déployé la solution avec Songmic, qui est un vendeur Amazon, où on a intégré la solution avec les applications métiers de l'entreprise. Un autre use case, c'est on a utilisé notre solution Wi-Fi 6, également Air Engine Wi-Fi 6, avec au niveau des environnements haute densité tels que les stades, au niveau en Suisse ou en Algérie maintenant, récemment. Donc, on est capable de connecter le maximum d'utilisateurs simultanés sans impacter la qualité. Thank you.
Dans la session suivante, nous nous concentrerons sur le Wi-Fi 6 et les technologies clés. Le Wi-Fi a été mis à niveau à Wi-Fi 6. Cela signifie une nouvelle ère pour nous tous. Donc, dans cette nouvelle ère, qu'est-ce que le Wi-Fi 6 apporte à nos vies et quelles sont les principales caractéristiques? Pour trouver des réponses, nous sommes honorés d'avoir à nouveau M. Youssef Boukari pour parler de comment rendre le Wi-Fi 6 plus intelligent avec la technologie d'antenne intelligente 5G de Huawei.
Bonjour tout le monde, je m'appelle Youssef Boukari, CTO de la partie Datacom au niveau de Huawei EBG Nord-Afrique. Durant cette session, je vais vous présenter les concepts de base derrière l'utilisation des antennes intelligentes issues de la 5G. Si après l'agenda, donc je vais commencer par une introduction sur le concept de base des antennes intelligentes, notamment la commutation entre les antennes, le contrôle des déphaseurs et le troisième volet qui est le contrôle de la géométrie de l'antenne. Puis, je vais vous donner un overview sur les techniques MIMO utilisées avec les antennes intelligentes. Et enfin, l'utilisation et l'adoption de ces techniques d'antennes intelligentes au niveau de notre solution Air Engine Wi-Fi 6 et des techniques telles que le multi-user MIMO et OFDMA, qui constituent actuellement deux piliers de notre solution Air Engine Wi-Fi 6 et ce qui est une conception unique à notre solution. Afin de comprendre le concept derrière les antennes intelligentes, considérons qu'un point d'accès doté d'un port puisse communiquer avec avec une station mobile. Donc, naturellement, on veut que le point d'accès pointe sur la direction de la station, que ce soit en transmission ou en réception. Et bien entendu, ceci va nous permettre, bien entendu, d'avoir une meilleure signalisation à destination de la station, donc en réception sur la station, c'est en downlink, et une meilleure signalisation en uplink sur le point d'accès, donc la réception du point d'accès. Et également, on aura moins d'interférences. Les techniques traditionnelles d'antenne, donc généralement, utilisent des antennes omnidirectionnelles ou directionnelles. Donc, du fait, elles sont incapables d'assurer une bonne couverture au cas où la station est en mouvement ou se déplace de sa position. Pourquoi? Donc, parce que ces antennes-là sont directionnelles et sont fixes. Afin de pouvoir suivre la station, on doit avoir des antennes qui ne sont pas fixes, mais plutôt qui sont adaptatives. Donc, ce concept d'antenne intelligente n'est pas défini au niveau du standard 802.11, mais plutôt c'est une conception propriétaire à notre solution. Maintenant, supposons qu'on connaît la direction de la station. On a trois options de base pour créer des antennes adaptatives pouvant suivre la direction de la station. Donc, la première option, c'est de switcher et de commuter entre les antennes. La deuxième option, c'est de contrôler les déphaseurs. Et la troisième option, c'est de contrôler la géométrie de l'antenne. Donc, pour démontrer le contrôle des déphaseurs, supposons on considère un signal en bande de basse, donc venant de la direction de l'arrivée θ sur le schéma. Et donc, on calcule le signal, bien entendu, après le combineur, donc y de t. Donc, naturellement, on veut que phi soit égal à 2pi d sinus θ sur lambda. Donc, sans entrer dans le calcul, c'est la deuxième option en termes de calcul et déphaseur. Ça va nous permettre quoi? Bien entendu, ça va nous permettre d'avoir le diagramme sur le schéma, donc illustrant la réponse spatiale des deux déphaseurs, donc les deux antennes, pointant sur des angles de moins 30 degrés à plus 30 degrés. Cette approche peut être étendue à plusieurs antennes. Donc, on a fait le calcul pour deux antennes, mais on peut également étendre la méthode de calcul à plusieurs antennes. Donc, ce concept est très utilisé au niveau de la technologie 5G, plus précisément sur le concept de contrôle de la géométrie de l'antenne consiste principalement à avoir une antenne polarisée verticalement. Donc, on commence par un monopôle central de radiation entouré par 5 éléments passifs ayant chacun deux états contrôlés par une diode et soit l'état fondé ou grounded, donc agissant en tant que réflecteur, et ou bien c'est le deuxième état, c'est flottant, et flottant agissant en tant que direct. Et comme illustré au niveau du schéma. Quand tous les éléments passifs sont en état flottant, ils changent difficilement la signature du monopôle. Et donc ça, et on aura quoi? On aura une omnisignature polarisée verticalement. C'est au niveau du plan AZ. Quand un ou plusieurs éléments passifs sont fondés, donc grounded, donc ils agissent comme étant des réflecteurs, plutôt, formant une signature directionnelle polarisée verticalement, ce qui est en fait c'est une signature opposée au réflecteur du plan AZ. Le concept des antennes intelligentes avec plusieurs entrées, plusieurs sorties, MIMO. Au niveau réseau Wi-Fi, donc plusieurs antennes en transmission et réception sont importantes. Et on peut utiliser une antenne intelligente, bien entendu, pour chacun des ports. Ceci nous fait quoi? Ceci va nous permettre d'exploiter une diversité de multiples chemins. Donc, la propagation du signal prendra plusieurs chemins. Et dans la transmission de plusieurs flux spatiaux, il est important de considérer différentes antennes directionnelles par port, ce qui va permettre d'avoir un niveau de signal élevé, comme le montre le schéma. L'implémentation du concept d'antenne intelligente au niveau de notre solution Air Engine Wi-Fi 6 avec le multi-user MIMO a introduit, bien entendu, ce nouveau concept de multi-user MIMO en uplink a été introduit au niveau du Wi-Fi 6. Principalement, les anciennes générations telles que le Wi-Fi 5 supportent uniquement le multi-user MIMO en downlink, pas en uplink, ce qui permet bien entendu d'avoir moins de densité de connexion en uplink et des risques de collision. Donc, pour avoir une bonne orthogonalité des stations, donc, le multi-user MIMO sont choisis séparés en espace, principalement, et les signaux doivent être relativement élevés. Donc, il est naturel d'utiliser, bien entendu, les antennes intelligentes avec le multi-user MIMO pour réduire les interférences. Donc, pour réduire les interférences au niveau de ce concept-là. Donc, les antennes intelligentes et leur utilisation avec le WebDMA. En fait, l'une des améliorations du Wi-Fi 6 est l'introduction, bien entendu, des fréquences orthogonales, Wi-Fi Access, où la transmission et la réception à partir de multiples stations, bien entendu, sont faites sur des sous-bandes orthogonales. L'antenne intelligente est une entité physique, normalement broadband, dont le contrôle est intégré dans l'algorithme de planification de l'OFDMA et le multi-user MIMO. Donc, ce qui va constituer, bien entendu, l'un des avantages de notre solution Air Engine Wi-Fi 6, c'est d'utiliser conjointement le concept de multi-user MIMO avec OFDMA. Par rapport au design, donc notre solution Wi-Fi 6 utilise déjà un design compact des antennes intelligentes, qui est caractérisé par, bien entendu, cette notion d'un design compact, employant un nombre important d'antennes ou de modules dans une petite forme. Et notre design, bien entendu, va inclure la double polarisation de matrices, également les matrices double bande verticale et un focus sur le contrôle de la géométrie de l'antenne. Donc, l'utilisation de métamatériaux également au niveau de ces antennes et les algorithmes, bien entendu, de training du faisceau basé sur la 5G. C'est une intégration parfaite, bien entendu, entre également l'OFDMA et le multi-user MIMO, avec bien combiné également avec les antennes intelligentes. Donc, ce qui va nous permettre, bien entendu, d'avoir un réseau simple et ce qu'on voit schéma suivant, donc le design de notre antenne intelligente, donc avec des modules top, des modules down et des modules bottom. Donc, comme récapitulatif, donc, les antennes intelligentes sont basées sur des technologies approfondies telles que le beamforming hybride, bien entendu au niveau de la 5G NR. Et également, un autre concept, c'est la partie également qui apporte des avantages significatifs aux clients. C'est, mis à part les antennes intelligentes, le Wi-Fi 6 apporte plusieurs challenges au niveau de nos réseaux et les antennes intelligentes, bien entendu, inspirées de la 5G, offrent un design compact, une intégration totale entre l'OFDMA, le multi-user MIMO et l'antenne et des performances inégales. Donc, merci.
Merci Monsieur Boukari pour votre discours. L'année dernière, Wi-Fi 6 a été présenté pour la première fois dans l'un des plus grands événements TIC égyptiens, Cairo ICT. Suivons ensemble.
Hello friends online. I am Qiu Guohua, Director of Huawei Cloud Managed Network Domain. The topic of my presentation is building one-stop digital enterprises with Huawei's Cloud Managed Network solution. With digital transformation 2.0, more and more new applications are adopted, driving changes in office, production, and lifestyle, such as AR and VR in education, electronic shelf label, self-service checkout, and fast rollout of retail outlets. Our manufacturers need IoT devices to monitor temperature and humidity. Video conferencing and mobile office pose great challenges to office networks. All these represent the new challenges network faces. With the rapid development of these applications, enterprise networks face these 6 challenges. To cope with such challenges, Huawei Cloud Managed Network, a user experience-centric solution, is continuously enhancing its 3 core values: simplified, smart, and superfast, based on customer scenarios. Simplified, user experience-centric deployment. Smart, AI-based intelligent O&M for both wired and wireless network. Superfast, business-centric ultra-broadband connectivity. The aim is to create high-quality service experience and accelerate digital transformation. Next, I will share with you along these 3 core values. With the Cloud Campus mobile app, Huawei implements simplified management throughout the life cycle, including procurement, deployment, acceptance, and O&M. In the procurement phase, we provide scenario-based packages, recommending the most suitable models and the optimal number of devices based on scenarios, saving the trouble of manual selection. During deployment, the Cloud Campus app can scan the barcode to bring devices online. No technical requirements on the operators, which greatly reduces deployment costs and improves efficiency. During deployment, scenario-based configuration is distributed automatically. No need for manual configuration. During acceptance, over 40 mobile acceptance tools can measure network experience and enable one-click acceptance. During O&M and inspection, the network, device, and user status are visualized. Simplified full lifecycle management can improve efficiency by 60%. In multi-branch scenarios, the cloud-managed network has built-in SD-WAN capabilities, supporting convenient deployment of enterprise branches and campus egress points. With ZTP, no need for engineers to go on site. With the 5G cabling-free and fast deployment features, enterprises can deploy networks quickly. In addition, the platform provides a wizard-based automatic configuration UI for site deployment, network orchestration, application policy provisioning, and visualized fault location, greatly simplifying branch network management. In user access layer, the cloud-managed network collaborates with WeLink to enable Wi-Fi access in one click. Users do not need to enter passwords. WeLink user ID is used to obtain access rights. WeLink login password is updated regularly in the backend. Users can access Wi-Fi network seamlessly. The network automatically identifies WeLink endpoints and accelerates their audio and video services in real time, which significantly improves video quality, giving WeLink users simple and secure experience. In the future, network will connect everything, especially between people and things and between things. Back in the Wi-Fi 5 era, Huawei launched the industry's first Wi-Fi and IoT convergent solution. Huawei Wi-Fi 6 has inherited the IoT card extension from the previous generation and have expanded it to more than 70 partners. With more than 400 APIs, partners and Huawei serve customers in retail, manufacturing, healthcare, and education. A supermarket chain with over 1,500 branches globally found price tags too slow to update and prone to error, and decided to use ESL to update prices by batch. With Wi-Fi and IoT in one box, the number of network devices went down, so did the deployment costs, and the maintenance efficiency improved. That is the simplicity offered by cloud management platform. Next, let's take a look at cloud-based intelligent O&M, the experience-centric O&M that shortens fault response from days to minutes. Campus Insight supports unified O&M of wired and wireless networks. For wired network, accurate issue reporting supports quick fault location and handling. For wireless network, KQI and KPI guide continuous network optimization. For instance, O&M personnel on site can use Campus Insight to check the health status of wired network. They may find performance to be abnormal. They can view details and find the abnormal metrics and go into the issue analysis page to view the root causes and fix it. Initially, it may only be an indication of poor network performance. The issue analysis page of Campus Insight can show root causes, which may be port congestion, attack packets, link exception, or others. In addition, the O&M data is open to big data analysis and can support various application requirements in many industries. According to data features, Campus Insight supports secondary development in different ways through RESTful northbound interfaces. Resource data like devices, interfaces, links, and boards, and health data like health evaluation and issues can be obtained. Through Kafka northbound interfaces, Kafka consumer APIs can be used to consume data collected via telemetry. The openness and programmability of Campus Insight enables partners and end users to leverage the values of data and combine network data and industry applications to create infinite possibilities. Next, we turn to the super-fast access of cloud-managed network. The cloud management platform can manage 5G ARs. Built with Huawei's leading 5G technologies, such as TDD, FDD, aggregation, 5G AR support full time slot super uplink, which improves the uplink rate at the cell center by 20 to 60% and at the cell edge by 2 to 4 times. This meets high uplink rate requirements in various industry scenarios. The new series uses a brand new forwarding architecture. According to Tolly testing, the forwarding performance is 3 times that of the competing products in the industry, sufficient to meet requirements in the next 3 to 5 years. In addition, the whole series of 5G AR supports AFEC WAN optimization, ensuring no video frame freeze even when packet loss rate is at 20%. The cloud management platform supports Wi-Fi 6 products also powered by Huawei 5G. First, I want to introduce Huawei's leading dual-band smart antenna. In multi-partition office area with mobile office services, wireless signals need to be flexibly adjusted based on the scenario and access density. Otherwise, user experience will deteriorate. With a unique hardware design, the antennas are laid out in a butterfly shape to achieve comprehensive multi-beam coverage without increasing the AP size or affecting aesthetics. Each AP offers 2 to the power of 48 beam combinations. The more beam combinations, the more accurate the coverage can be. The antenna scheduling algorithm can flexibly adjust the beam direction to track the SDA movement in real time. This way, signals follow users as they move, while maintaining signal stability. Second, as the SDA density increases, the WLAN throughput and bandwidth per user will drop sharply due to contention. This is like on highways. When there are lots of cars, traffic will be congested. In large bandwidth or high-density scenarios, user experience would be affected. That is why Huawei has developed Wi-Fi 6AP with the most spatial streams in the industry. The 2.4 GHz and 5 GHz dual radios support up to 16 spatial streams and up to 10.75 Gbps rate. In addition, Huawei's exclusive MU-MIMO and OFDMA joint scheduling can increase network throughput by more than 40%. This addresses the issue of slow decrease of bandwidth per user in high-density scenarios and provides good experience even in ultra-high-density settings. But not all scenarios require high bandwidth or large capacity. The flexibility to support different scenarios is highly desirable. Huawei is the first to offer software-defined radio technology, which controls the number of RFs and RF functions through software. An air-engine Wi-Fi 6AP can support different scenarios and provide WLAN capabilities and functions. Next, I will share two cases of cloud-managed network. The first one is Lanzhou University, who manages tens of thousands of network devices on the cloud platform, supporting 40,000 users with stable campus network. Wireless networks have long suffered from problems like weak signal coverage, long authentication time, poor roaming experience, and video call freezing. Traditional approach cannot address these issues due to the lack of monitoring and fault locating. With cloud-based intelligent O&M, no local server is needed. Data is collected and analyzed in real time. With big data analysis and algorithms of AI on the cloud, they can learn network patterns and identify faults and their root causes. Network faults can be handled in minutes. The second case is a Saudi Arabia carrier that has deployed cloud-managed network. The carrier is the largest and most prestigious telecom operator in Saudi Arabia, especially in the public sector. It is also a VAP of Huawei. After many discussions, the carrier highly recognized the values of Huawei cloud-managed network solution, which is in line with its digital transformation strategy. The carrier provides managed services to end customers. LAN-WAN convergence on the unified platform extends the carrier's services from WAN to LAN, increasing revenue. For different scenarios, more than 10 managed service packages are offered, such as managed routers and managed Wi-Fi. These packages can be sold separately or bundled together, giving customers great flexibility. Automated planning and deployment tools shortens the service provisioning from months to days. AI-powered O&M greatly simplifies network O&M, reducing OPEX and improving end customer satisfaction. Huawei Cloud-Managed Network Solution is dedicated to providing users with simplified, smart, and super-fast experience. We're committed to enhancing solution capabilities based on customer requirements. In the future, Huawei will continue to work with our partners and MSPs to provide high-quality cloud-managed network solution and services for users in all industries. Our partners will now share with you their success stories. That's all from me. Thank you for listening.
Merci à tous nos experts d'avoir partagé les technologies d'innovation réseau de pointe telles que Cloud Campus et Wi-Fi 6 et les meilleures pratiques dans des domaines spécifiques. Vous pouvez nous contacter à travers notre site web pour plus de détails. Et n'hésitez pas à nous contacter sur le site internet de IP Cloud pour vos éventuelles suggestions ou remarques.
Les meilleurs outils offrent les meilleurs résultats. Il est important d'utiliser des outils professionnels pour assurer la couverture Wi-Fi de votre campus. Alors que les activités bureautiques passent au sans fil, le bureau égyptien de Huawei se tourne vers l'outil WLAN Planner pour offrir des expériences sans fil optimales. Commencez par importer le plan d'une zone donnée, le format CAD ou CAD et d'autres formats d'image sont pris en charge. Ensuite, Définissez les paramètres de l'environnement. L'outil peut employer des algorithmes IA pour identifier automatiquement la disposition des salles, notamment les murs, surface en verre et top stable. Configurez à présent la zone de couverture. L'outil peut déployer automatiquement des positions de points d'accès et des paramètres de plan pour un déploiement sur une zone en quelques minutes. Pour vérifier l'efficacité de la planification, simuler les signaux, l'outil prend en charge la simulation 3D, offrant une visualisation intuitive de la couverture de signal. Vous pouvez également planifier des trajectoires de passage afin de simuler l'itinérance STA. L'outil affiche en temps réel la qualité du signal à chaque point de la trajectoire. Ainsi, vous pouvez consulter facilement la qualité du signal en itinérance. WLAN Planner est un outil de planification de réseau sans fil développé par Huawei. S'appuyant sur les années d'expérience de Huawei dans le domaine de la radio sans fil, cet outil dispose d'un bureau étendu de scénario et d'un moteur de planification IA puissant. En planifiant les résultats à l'aide de WLAN Planner, vous effectuez votre déploiement sur site en connaissance de cause. Cela permet de réduire considérablement l'ajustement et la calibration des réseaux Wi-Fi sur site, raccourcissant les délais de déploiement. Enfin, exportez un rapport de planification de réseau Wi-Fi de qualité professionnelle. Il vous aidera à installer facilement des points d'accès et à réaliser leur câblage dans une demi-journée seulement. Étudions à présent le résultat du déploiement.
Hello, today I have Wi-Fi 5 and Wi-Fi 6. You know that Wi-Fi 6 supports 4 times higher bandwidth than Wi-Fi 5. Also, the Wi-Fi 6 supports higher transmission speed, super long stay, and super higher concurrency.
Chers invités, mesdames et messieurs, c'est la fin de Huawei North Africa IP Cloud 2021. Merci de votre participation.